Hi, we are from Group 9 and today we are going to show you some example and explain about Gauss-Jordan elimination method. So this method is basically a method we use to solve a linear equation or linear system. So let's take a look right here. Let's say this is our linear system and we want to find x, y, z. So we can use the Gauss-Jordan elimination method. First, we need to turn this equation into a matrix form. So you can use this. For A, we just put the coefficient B1, B1, C1, and so on. For X, you just put the variable S, Y, Z. For B, just put the D1, D2, and D3. So for Gauss-Jordan elimination method. So our first step is to construct an augmented matrix form. We can do that by just put your E on the left side and B on the right side. So you can just do this. Okay. So this is your augmented matrix form. And now what you need to do is reduce this matrix into RREM by using ERO operation. So I'm just going to do this. With RREM should get like this. Do take note that this value right here is different from the value right here because we already used the ERO and I don't think it's possible to get the same value. Actually, I'm just going to write this as M so we don't get confused. Okay. So now we done this, we can get our solution for X, this one. The solution for that is this value right here. You can just write it. Solution for X is equal to M1, M2, so we can get our solution straight away, unlike if we use the Gauss elimination method. Let me show you an example. If we have our RREM like this. So if we have RREM like this, our solution for X should be 1, 2, 3. So that's how you do the Gauss-Jordan elimination method. So first, you need to have the linear equation and then turn it into matrix form, then construct it into this matrix and then reduce it using ERO until you get RREM. Okay. Then you can find your solution for X right here. So that is all from me. Thank you.
Okay, now I will show you some example of solving linear equation using Gauss-Jordan method. And this is our linear equation. First step is we change it into augmented form. So this is our augmented form. So by using Gauss-Jordan method, we will making this value and this value become 0. And then this diagonal become 1. So next, after we construct augmented form, we will eliminate this value, -2. By doing that, we will using row 1 plus row 2. And then we will getting this value over here. So as you can see, this value become 0. And next, we will make it this value become 0. So we will using for row 2, we will using row 2 plus 2 times row 1. And for row 3, we will using row 3 minus row 1. And this is value that we get, that is 0. And next, we will make these these two over here become 1. So at row 2, we will divide it by 2. So when row 2 is divided by 2, we'll be getting this value. This value over here become 1. So as you can see, we slowly getting our value over here, and this diagonal. And next, we will making this value over here become 0. So to make that value that to become 0, we will be using row 3 minus 2 times row 2. Then and we will be getting value over here is 0. Then next, we will make this -31 become 1. So we will make it row 3 divided by -31. So row 3 is divided by -31. we will getting 1 over here. So we get diagonal is 1, and this 3 we got 0. Now we want to make this value become 0. So to make that happen, at row 1, we will make row 1 minus 9 times row 3, and at row 2 we will make row 2 minus 19 over 2 times row 3, and then this is the value that we got. So our solution is complete. We got 0, 0 over here, and this diagonal become 1. So from over here, we will getting our x is 3, and y is 4, z equals to 1.
For this example, we have the linear equation that is x plus 3y plus z equals to 10, and then x minus 2y minus z equals to negative 6, and 2x plus y plus 2z equals to 10. We need to put that linear equation in a metric form. We will negative the column 1, negative r1 plus column 2, and then we will get column 1 the same, 1 3 1 10. The new column 2 we will get 0, negative 5, negative 2, and negative 60. For column 3, we will put negative 2 column 1, that is negative 2 r1 plus column 3 r3. We will get 0, and then negative 5, 0, negative 10. We can change column 2 and column 3 because at column 3 we already have the 0, this one. So we just change the column 2, change with column 3. We will get the column 1 is the same, 0 minus negative 0, negative 5, 0, 0, negative 5, negative 2. Can negative 10, negative 60. We can remove this 5 by make negative r2 plus r3. That means we will plus column 2 with column 3. So the new one we will get 1 3 1 10 0 negative 5 0 negative 10. Okay, and then the new column 3 we will get 0 0 negative 2 negative 6. We can divide column 2 with negative 5 and column 3 with negative 2. We will get first column is the same, 0 1 0 2 0 0 1 3, and then we get REM. Okay. After we get REM, we need to get RREM using Gauss-Jordan method. We can multiply column 2 with -3 plus column 1. We will get 1, 0, 1, and then the rest is the same. We still have 1 right here, so we need to eliminate this one. We can multiply column 3 with -3 and then plus with column 1. The answer we will get 1, 0, 0, and then -3 plus 4 equals to 1. Okay, and the rest is still the same. 0, 1, 0, 0, 0, 1, then 2, 3. That's how we get RREM with Gauss-Jordan method.
Hi, so this is an example of the equation using the Gauss-Jordan method. So this equation we put in the metric form like this. Okay, so the first thing we need to do is 3, 0, and 3. We must make this number become a 0, and also these three numbers and these three numbers 2, 2, and 1 become a 1. So the first thing we try to make this number become a 0. So we put a -3/2 R1 plus with R2. So we got this value. So for the next step, we try to make this number 3 become a 0. So -6 R2 plus with R3. So this is a value. And the next step, we try to make these three numbers, which is 2, 1/2, and -8, become a 1. So we do the operation 1/2 R1, 2 R2, and -1/8 R3, and it will become 1. So for the next step, we try to make this three number become a 0. So what we're gonna do is we make this 1/2 R3 plus with R1 and -3 R3 plus R2. So we get these two numbers become a 0. And after that, we make this number become a 0, -1/2 R2 plus with R1. So we will get 1, 0, 0, 0, 1, 0, and 0, 0, 1. So this is the last step using this metric form. And after that, we just put x equal to 1, y equal to 4, and z equal to -2. But in this question, we see that the equation for x, y, and z, which is unknowns, is in the fraction number. So we put 1/x equal to 1, 1/y equal to 4, and 1/z equal to -2. And after that, we just solve this equation. We got x equal to 1, y equal to 1/4, and z equal to -1/2. So that's all for